Okay, so until now, what we've had is the following thing. We know how to declare rats because we have constructors. So we can say that I have a rat x, which is a half, and y, which is 2/3, and z, and that's the default constructor. We also defined operator plus, so we can say something like x plus y, but how can we say z is equal to x plus y? The right-hand side, the x plus y, evaluates to a rat. The left-hand side, z is a rat. How does the compiler know how to do a sign? How does it know how to do that? And the answer is that when you declare a class, there are a couple of things you get free. One of those things is the assignment operator. This comes for free. You don't have to define that for the compiler, and it'll give you a default one. Sometimes the default's not good, then you can define it, which we'll see later on. But what's going to happen if you use the default? So let's say x. Let's say here is z, and it has a numerator and denominator. And let's see here we have something else. We say z is equal to like x plus y. Now whatever x plus y happen to be, let's say x plus y is 4 and 9. So what's going to happen is it just simply does a byte by byte or a bit by bit assignment. So it's going to essentially take this and carry it over to here, and it's going to take this and carry it over here, and so we're going to get a 4 and we're going to get a 9. Okay, so it does what we'd expect it to do. Now we're going to see about the output statement. How do I say output z? That we'll see in a little while. We already know how to set the numerator. We know how to set the denominator. There's assignment again. We'll check the output. We'll also check the input in a little bit. The question is, what about this one over here? What happens over here when we say z is equal to x plus y? So the z is equal to, well, z is a rat, and we know that assignment comes for free. But what happens with x plus y? What happens with that? Well, we know how. I'm sorry, not x plus y. What happens with x plus 5? So we know if we'd be adding two rats, x and y, we've already overloaded the plus operator. But here we have the left-hand side, which is a rat, but the right-hand side, the 5, is an integer, and so far we don't have any way of adding an integer to a rat. So that's where the other constructor that we haven't seen yet, there's another constructor up there which is called the conversion constructor. And the conversion constructor looks like this. It's a constructor, right? We have it right over here, right? It's a constructor. So it has the same name as that of the class. It has no return type. But notice it takes single parameter and okay, that was the wrong one. Here's the right one. It's a constructor, right? So it has the name of the class, which is rat. It takes a single parameter, I. And what it's going to do is it's going to take the I and put it into the numerator. And it's going to put a 1 in the denominator. So it's in this case, if I give it a 5, it's going to put a 5 in the numerator. Here's the numerator. And it's going to put in the denominator, it's going to put a 1. So this is going to be equivalent to the integer 1. And the reason this thing is called a conversion, 5, the integer 5. So the reason this thing is called a conversion constructor is because basically what it does is it takes an integer and converts it into a rat. And when does it do this? It does that. The compiler is trying to be helpful over here whenever it would need a rat. So when the compiler sees this expression x plus y, it says, well, I don't know what to do with, I know x is a rat and I know 5 is an int. I don't know how to apply plus to a rat and to an int, but I do know how to apply a plus to a rat and a rat. Is there any way that I can convert this thing to a rat? Well, by the very fact that we've provided that with the conversion constructor, it's going to actually take the x, let's say x is going to be equal to 1/5, 1/2, and it's then going to take the 5, convert that also to a rat by using the conversion constructor, making it 5 and 1, and now it knows how to add two rats, and so it's going to give us the rat, which is 5.5. Okay, so that's how the compiler knows how to take care of something like x plus y, x plus 5. Now what about the other side? This actually gets quite interesting. How about if I say not x plus 5, but if I say 5 plus x? Before we see that, let's just make sure we understand what's going on over here. What does it do with this expression? What it does over here is it takes, well, it says x. Now the plus, it calls operator plus. So it calls x dot operator plus. Now it's going to try to pass the 5 in, so it can't, so it can convert the 5 to a rat. And so it's going to say x dot operator plus, calling the conversion constructor rat on the 5, and it's going to give us a rat on the left-hand side and a rat as the parameter. That's the way that thing works. But now what happens if we do the other thing? What happens if we say 5 plus x? Well, this becomes much more complicated. And in fact, it's really not going to work. So if we look at z equals 5 plus x, this will not work. Why not? Because what's going to happen is, again, it's trying to add an int to a rat, but it's going to try to do 5 dot operator plus x. Now, this makes no sense at all to the compiler, because 5 is not an object, right? 5 is just a built-in type. It's a built-in int, so you can't apply the dot operator to it. So you might say, well, we have a conversion constructor. Why doesn't it simply take the 5 and convert it to a rat? So I'd have a rat for the 5, and there's 5 over 1, and then that rat could have operator plus assigned to it and passing x in as the parameter. And the answer is it simply will not do that. It will do it, in other words, the compiler will call the constructor for the right-hand side, which is going to be a parameter, but it will not call it to create a rat on which to do an operation. It simply won't do it. So does that mean that we can't say 5 plus x? Well, we can say 5 plus x, but we have to define another operator. What we'd have to do is we'd have to say something like, I'm declaring a new operator, and I'm going to call the operator operator plus, and we're going to overload it again, but this time what we have to say is that operator plus is going to take an int and an int, or it's going to take an int and a rat. So I can either say it like this, or an int and a rat. This has advantages, we'll see in one moment, and it's going to return a rat. So what will happen over here is when it sees the 5 plus x, it's going to say, well, it's going to see 5 and it's going to say x. Well, x, it knows it's a rat. It can now apply the conversion constructor to create this parameter because it's not making it the left-hand side. It's just going to be a regular parameter. And then my operator plus, I will then write it so that it takes the rat on the left-hand side. Let's say this is rat p and rat q. It's going to take p and q and add them together, and it's going to return the rat that's the result of that operation. Now, once I have that, then I can get rid of both of those, the other operator plus as well, because this will work. This case will work whether the rat, the int is on the right or the int is on the left. The important thing to realize here, though, is this is no longer going to be a member function, because the member function is always invoked with the dot operator. The member function is always, I have some object on the left-hand side, and then a dot, and then I have some kind of member function, some kind of operator, or some kind of member function after the dot. This is not going to be that. This is going to be a regular function defined outside of the class that's going to be able to do that arithmetic. Now what's left is, how do we do the input and output? And we'll see that momentarily.